going to be talking about how to write ionic compounds. Now, in the previous video, we talked about how to write covalent compounds, but for ionic compounds, it's slightly more complex, but we will get through this. And I want to give you a heads up. Writing out the compound is pretty simple, but solving them and balancing them out is slightly more difficult than what you would do for a covalent compound. So the first thing we're going to do is go through all 5 steps of writing out a chemical form of ionic compounds. So the first step is writing down the symbol of the first element. So if the element is oxygen, you're just going to write O. Now, here's where it already starts getting tricky. The second step is to find the oxidation number of the first element. And I'm going to show you exactly how you can find the oxidation number of an element. This is a really great picture of finding oxidation number for each element. So it starts off with +2, +3, +4, -3, -2, and -1. And remember, hydrogen will always be -1. And you're always going to go by the columns, up and down, which are also called the groups of the periodic table. Moving on to the third step, you're going to write down the symbol of the second element. And you're also going to find the oxidation number for that element as well. And now here's the slightly more trickier part. So after you find the oxidation numbers for both and you write both elements down, you're going to have to balance out the atoms. So for example, if one element has 2 atoms and another element has 5 atoms, that means they are unbalanced. So what you're going to need to do is find a common multiple for each one. So for example, let's say one of your first elements has 2 atoms and your second element has 5 atoms. You're going to need to find a common multiple between 2 and 5. I would suggest starting off with the biggest number. So we're going to start off with 5. When you're counting by 5s, 10 comes next. 5, 10. So keep 10 in the back of your mind. Now let's go on to the first element. You're going to count by 2s. Count until you reach somewhere close to the multiple of the second element, or the element with the biggest number. 2, 4, 6, 8, 10. Okay, so that means both elements have a common multiple of 10. So now I'm going to show you an example and I'm going to walk you through it. So we're going to look at potassium nitride. So let's go to our periodic table and find potassium and nitrogen. So we can see that potassium is right there. It's the letter K. And we can see that nitrogen is right over here under the -3. So the group for potassium, except for hydrogen, is +1 oxidation. And the group for nitrogen has an oxidation number of -3. So now we have to balance out +1 and -3. This is what it looks like visually. We have one oxidation number of +1 and we have another oxidation number of -3. So by common knowledge, I'm sure that we all know that 1 has a multiple of 3. So what will we do? What we would do is add 2 more potassiums. And now they are balanced. They cancel each other out. There are 3 positives and there are 3 negatives. So now it can be called potassium nitride. And did you notice how these don't have prefixes? Yeah. Ionic compounds do not have prefixes, because, like I just showed you, they need to be balanced out. +3 and -3. I hope this video was helpful, and I'll see you in the next one. Hey